people here. So every day put acid right in the oven. Wow. You have an emergency vehicle lining up. Take all 20 into emergency house, because that is really toxic. So what you do is, if you're going to do that, make sure never pour the acid while you're in this room. If I see that, I can smell it. I'm going to kick you out. You cannot do any more experiment because you don't listen to the safety, instruction. Okay, everybody. I don't want. If you pour it, you see the brown smoke coming out, and if you don't do it in the, inside the hood, you can smell it. Someone is going to start coughing. I'll get coffee first, okay? So I can smell it. So all right, so here, and then I put the two plate. Usually, this is going to dissolve so fast. But if you doesn't react that fast, put on top of hot plate. Just warm it up, not to boil. It's not for you to boil. It's to warm it up. So now you're in a camp 110. I want you to remember, every 10 degrees Celsius rise in temperature, you double the chemical reaction. So have you tried that? You're going to do something, you use some warm water or warm, right? You will react faster. Okay? So you put it on top and then turn on, hot plate, warm it up, not to boil. Okay? In about 5 minutes, the reaction is going to be complete. So this is what you're going to do. You add it there. This is the reaction. I'm going to ask you okay? Which reaction you think is going to go? Which reaction? The same form of copper nitrate, same form of copper nitrate. So, are they both good? Think carefully what you have done so far. I want to see how many of you say the first reaction or what's the reaction is fine, or prefer the first reaction. Raise your hand. First reaction, nobody? Nobody will take the reaction? How about second? Everybody? Okay, so why not the first reaction? Huh? Why not the first? Well, it's good. It's a single replacement, right? Single replacement reaction. Why would that reaction go in that route? I want to hear one of you tell me, yeah?
Need the extra hydrogens to react to
No.
this reaction.
No, that's the wrong answer. I don't want to hear one correct answer. Tell me.
You're missing oxygen then. So if you have a 2H and 2NO3, where's the oxygen coming from the H2O? Just from the air?
Well, no, I'm sorry. This would be a hydrogen gas.
Oh.
It's just single replacement, right? Single replacement reaction, isn't it?
Yeah.
Single. This perfect balance out. So why? I want to hear one person tell me, okay?
Is it because it's a
No. The single replacement. There's no base. Yeah.
Is copper nitrate the one that's really unstable and breaks off into
Thanks. Thank you. Yeah. I stress you guys. Yeah.
Because copper is below hydrogen.
Ah! Oh! You already forgot only one person, no? Activity series, didn't I tell you memorize that thing? Huh? And then, what was 2 days ago? I told you, make sure you remember this, remember because it could be on the exam, and then here today, boom, here it shows up, and then only one person can tell me that because, yeah.
Isn't copper replacing hydrogen in both of them? I don't get it.
Activity series, look at it. Tape, activity see position of hydrogen and the copper. Is copper about hydrogen?
Yes.
Yes?
Wait,
Oh! Okay. Now, some think that the copper is about hydrogen. Some say things like, yeah, hydrogen is about the copper. Look at that, take out the table. Look at it.
Copper is below hydrogen.
Okay, so with the copper kick off the hydrogen? Oh, no. So, that's what I'm telling you. This lab involves so many chemical reactions and then give you the full review of what you have done so far. Okay. Now you know activity series come into the picture, right? No?
I don't get how the activity series tells us that the second equation is
Because the copper is hydrogen is more reactive than the copper, according to the hydrogen above. So which between hydrogen and copper, which is more active?
hydrogen.
So hydrogen, and then because the copper want to go into the solution, but you cannot, because active does means they want to dissolve it, react. But copper will not react. What the activity series is? Okay. Copper is not reactive, active as a hydrogen, so hydrogen stay. You got it? That's what the activity series is. You remember? Okay?
Yeah, I get that part.
Yeah, you get a part, then how come if there's a reaction?
It just looks to me like the hydrogen is getting replaced in both.
Oh, see, that's wrong. That is wrong because that's a perfect single replacement reaction. You can balance it. Okay?
When hydrogen goes to H2O, it's stable and it's happy, so it's not being replaced.
Then I'm going to give you a review, okay?
It's just H2.
So, okay,
it's
what
H
do you...
plus, and it's not, the hydrogen isn't happy, therefore the copper would take the hydrogen.
Okay, he explained it better. You understand now? Because now every reaction you're going to look is which one is more reactive. So that's why I told you to memorize that chart, proper sequence for the position of each element. There are only 4. How hard is it for you to know? Good. Only one person tell me that, I'll be sad that all this time I spent tell you and then nobody tell me the right answer. This have one. That's good. All right. So this one's no go. Okay. Now you see what kind of reaction it is. Copper. It's not a single, it's not a double. You just oxidation reduction. You look at the copper. Yeah. Is it the iron? Huh? I already identified the copper. No charge becomes the positive full charge. So copper gain or lose electron?
Loses
lose electron. And say, okay, that is a redox reaction. See, this is what I'm telling you. This experiment involves something beyond all you have learned so far, and then give you, to think. So that reaction is, you see now, how do you identify that redox or no, not redox reaction? Everybody? You see a chemical reaction, and the first thing is that, okay. Now, you see there's a copper, no charge, and then here, copper, those electrons, that's oxidizing, right? Look at the nitrogen. If there's oxidation, there has to be a reduction reaction. Copper oxidizing, nitrogen, coal. Right? +4 for nitrogen, -2 for oxygen, so 2 and 2, so this cancel out. This is, the whole thing is negative. Okay, so how do you get a negative? -2 and 3. Right, everybody know how to do oxidation, okay? Oxygen is -2, there's 3 atoms. So nitrogen has to +5 so that the whole atomic atom is -1. Okay. +5 becomes +4. Nitrogen has to gain all those. +4 or +5 to +4 has to get how many electrons? 1. So its gaining electron is what? 3. Reduction. Because if copper you already identified is oxidation, so nitrogen has to be reduction. Okay? Everybody know? Now? I'm telling you because of this lab involves so many reactions which you have experienced so far. Okay, now this is a redox equation or reaction. Okay.